Have you ever looked up at the night sky and felt a shiver of wonder? Have you ever wondered what really lies hidden in the depths of space? Our galaxy, the Milky Way, is a vast realm of cosmic mystery and wonder. Like a majestic spiral spinning in the void, it is home to hundreds of billions of stars, each guarding its own secrets. From colorful nebulae to ravenous black holes, from enigmatic exoplanets to wandering comets, our galaxy abounds in fascinating phenomena that defy the imagination. Dear traveler, welcome. Today we're off to explore the farthest reaches of our galaxy. But before you set off on your next adventure, remember to like the video and subscribe to the channel so you don't miss a thing. Thank you, and have a great trip! A galaxy is a structure formed by the gathering of stars and their planets, interstellar gas and dust, and often containing a supermassive black hole at its center. A study published in 2016 estimated that the observable universe contained 2,000 billion galaxies. There are four main types of galaxy. Elliptical. These have an elliptical appearance whatever the angle of view. They have little interstellar matter, so contain few open clusters and give rise to few stars. There are also giant elliptical galaxies. Spirals. Made up of a disk of stars and interstellar medium, rotating around a central bulge. They have relatively bright arms. Lenticulars. These are made up of a bright central bulge and an extended disc-shaped structure surrounding it. Their galactic disk has no spiral arms and very few new stars. Irregular. This is the last category of galaxies, which includes others such as dwarf galaxies and compact blue dwarfs. The Hubble sequence gives a detailed description of galaxies, but only takes into account their physical appearance. But let's get back to our own galaxy, the Milky Way. Thanks to the European satellite Gaia, we've been able to reassess the conditions in which our galaxy was born. It probably formed like other galaxies, shortly after the Big Bang, around 12 billion years ago. Some regions even began to form 13 billion years ago. The oldest known star in the Milky Way is HE 1523-0901, 13.2 billion years old. In the beginning, our galaxy was a small bluish ensemble dominated by young fiery stars. Gas clouds, mainly hydrogen, abounded. A billion years after its formation, key structures began to appear. Globular clusters made up of small masses, the supermassive black hole at its center, and the bulge of stars. The creation of the black hole regulates the growth of galaxies by limiting the addition of matter. After a few billion years, the Milky Way's mass was large enough to reach a sufficiently high tangential velocity. This high velocity caused the ball of matter to become a disk with spiral arms. Stars formed in this disk. For a few billion years, some 15 young stars were born each year, taking advantage of the gas reserves. Today, the rate has dropped to 1 new star per year. This disk is itself surrounded by a spherical halo. The Milky Way was formed by gas accretion, but also by absorbing other smaller galaxies. We know that 10 billion years ago, it absorbed the galaxy Gaia Encelade. It would appear that it has not merged with a larger galaxy since that time, which is quite unusual for a spiral galaxy. The remnants of Gaia Enceladus, some 30,000 stars, are still moving through the Milky Way in the opposite direction to the other stars, including the Sun. At present, our galaxy is attracting material from two satellite galaxies, the Small and Large Magellanic Clouds. These are small, irregular galaxies located between around 160,000 and 200,000 light-years apart. The diameter of the largest is 14,000 light-years, even though it is a dwarf galaxy. Separated from each other by only 75,000 light-years, they follow an eccentric orbit that would have taken them into the vicinity of our galaxy. The clouds are linked by the Magellanic Bridge, through which stars from the small cloud travel to the large cloud. Researchers believe that the large cloud will collide with our galaxy in 2 billion years' time. Following this first collision, the mass of the Milky Way's central bulge will increase by a factor of 8, and that of its halo by a factor of 5. Our galaxy has a poetic name, the Milky Way. The galaxies M81, NGC 6872, and Z8, GND 5296 are not so lucky. When seen from the sky, our galaxy forms a long white streak. It's this milky appearance that gives it its name. In most cultures, we speak of a way, a path, or a river. In Greek mythology, the origin of the Milky Way is attributed to Heracles, son of Zeus and Alcmene. When Heracles was still very young, Zeus laid him on the bosom of Hera, his lawful wife, so that he could drink her milk and become immortal. When Hera realized she wasn't nursing her own child, she pushed him away. But Heracles held on until Hera violently pushed him away, causing a milky trail to spread across the heavens, giving birth to our galaxy. But what does our galaxy really look like? It looks like a flat disk. Seen from above, we see a spiral with a luminous center. Seen from the side, we see a white line, the edge of the galaxy. This is what we see from Earth. Galileo was the first to point his telescope at the Milky Way in 1610. He wondered how many stars it contained. He then realized that it contained an enormous number of stars not visible to the naked eye. But how to count them? In the 18th century, astronomer William Herschel had the idea of probing a small part of the galaxy and counting the stars. He then estimated the total number of stars it contained. In 1906, this work was taken up again by Jacobus Kapteyn, who obtained a more precise figure with the help of photography. Today it is estimated that there are between 100 and 400 billion stars in our galaxy. The Sun and its planets are only a tiny part of the Milky Way, which is thought to include at least 100 billion planets. There are an estimated 3,000 planetary nebulae. And let's not forget that among the exoplanets, several billion would be the size of the Earth. In the course of the 20th century, thanks to the work of Harlow Shapley, we come to understand that the solar system is eccentric in the galaxy. When we look at the Milky Way, we see that it is spread out 360 degrees around us, whether from the northern or southern hemisphere. Its luminosity is more or less the same everywhere. If we were at its center, we'd see more stars. If we were outside, we wouldn't see it everywhere, but only on one side of the sky. We now know that the Sun is located around 27,000 light-years from the center of the galaxy, halfway between the center and the edge. It circles the center in 250 million years, which corresponds to 1 galactic year. It has therefore made around 20 revolutions since its birth. It is currently located in Orion's arm, but this situation changes regularly as it rotates in and out of the galaxy's arms. But how big is this immense disk? We've measured the diameter of the central part, which contains the most gas and stars, at 100,000 light-years. Remember that a light-year measures 9,461 billion kilometers. The Milky Way in its entirety measures around 52,000 light-years. Its thickness, meanwhile, averages 1,000 light-years, but in some places it reaches 3,000 light-years. Still, that's a bit more than a CD. To understand the structure of the Milky Way, we made spectra of the main nebulae that can be seen in it. We noticed that some nebulae were moving away from us while others were getting closer. These nebulae are distributed like arms throughout the galaxy, which is itself in rotation. The Milky Way thus has the appearance of a spiral, or large whirlpool. The spiral shape naturally classifies it as a spiral galaxy. Its structure was discovered in 1951 thanks to radio astronomy, a branch of astronomy that studies the electromagnetic radiation of stars. The Milky Way is precisely a barred spiral galaxy, as its two main arms do not emerge from its center, but from a band of stars that crosses this center. Galaxies are rich in hydrogen. This emits radiation at a wavelength of 21 centimeters. Thanks to this radiation, the galaxy's spiral structure, mass, distance, and velocity from other galaxies have been revealed. At around 12 billion years old, the Milky Way should have been completely round. Its arms should have wrapped around it over time, but this is not the case. But why not? Because stars and nebulae pile up in certain places, forming a kind of traffic jam before they can continue on their way. These jams form the arms. We'll be exploring them later. If you look at the photos of the Milky Way, you'll notice that its center is very bright, orange in color, while the arms are more bluish. This tells us that the arms are where stars are formed, so they are young and hot, and blue in color. The stars in the center of the galaxy are older and cooler, and mostly red. By observing the movement of stars for 20 years, astronomers were able to calculate the mass of the object at its center, around 4 million solar masses. Sound like a lot? But it's only 0.2% of the Milky Way's total mass. An object that big can only be a black hole. The one at the center of our galaxy is Sagittarius A, first photographed in 2022 by Event Horizon Telescope, a set of 8 telescopes spread around the world and working together. To conclude this overview, galaxies are surrounded by a halo, a very luminous bubble. It is highly visible in some galaxies, less so in the Milky Way. This bubble is made up of stars and gas. This is where the Milky Way's 150 globular clusters are distributed. The Milky Way belongs to the local group, a cluster of around 60 galaxies measuring 10 million light-years across, which also contains the Andromeda Galaxy. The local group is itself part of the Virgo supercluster, which in turn belongs to Laniakea, a supercluster of galaxies. During our journey, we'll often come across the names of constellations. This is only to be expected, as constellations are used to locate celestial bodies in space, even if today's astronomers use more precise tools. A constellation is a group of stars linked together by imaginary lines. It was human beings looking at the sky who found that by linking certain stars together, we could obtain shapes. There are 88 constellations divided into two groups, 44 from each hemisphere. Some constellations are visible all year round, while others are only visible in certain seasons. Let's move on to our first destination, the solar system and its immediate surroundings. As you already know, our solar system is made up of the Sun and 8 planets orbiting it. These planets themselves have natural satellites that revolve around them. Some, like Saturn and Uranus, have rings made of gas and dust. As we move away from the solar system, we pass through two interesting zones. Firstly, the Kuiper Belt, and much further away, the Oort cloud. These two spaces are what we call comet reservoirs. You'll love traversing them, because comets, which look like luminous hairs spinning through space, are a marvelous sight. A comet is a roughly spherical body of ice and dust, up to several dozen kilometers in diameter. Its name comes from the Greek coma, meaning tail. As it approaches the Sun, part of its matter sublimates, and the star develops a dusty tail several million kilometers long. This material is visible from Earth, as it reflects the Sun's light. There are periodic and non-periodic comets. Comets from the Oort cloud are non-periodic, as they pass close to the Sun only once. Periodic comets pass close to the Sun several times, enabling us to predict their passage. Halley's Comet, which you've heard about, is one of these, passing close to the Earth every 76 years. First, we cross the Kuiper Belt, which extends beyond Neptune's orbit, around 4.5 billion kilometers or 2.8 billion miles from the Sun. It takes its name from its ring shape and from the work carried out by researcher Gerard Kuiper. The dwarf planet Pluto is part of the Kuiper Belt, along with its double Charon and most of the solar system's dwarf planets. Let me introduce you to the dwarf planet Makemake, the third largest of the dwarf planets. Its average temperature is minus 238 degrees Celsius, or minus 396 degrees Fahrenheit. It's an icy planet with no atmosphere. As you can see, we won't be here for long. Most of the objects in the belt were discovered recently, after 1992. The belt contains over 70,000 bodies over 100 kilometers or 60 miles in diameter. Most of these bodies are frozen asteroids and comets. Continuing our journey much further out lies the Oort cloud, made up of billions of comets. It surrounds the solar system, for it is neither a ring nor a cloud, but a sphere. It has never been observed directly, but is the result of calculations and hypotheses. Based on analyses of comet orbits, astronomers believe that the comets originated here, in the outer part of the cloud. The outer part could contain several trillion comet nuclei, separated from each other by tens of millions of kilometers. The objects in the cloud are composed of ices such as water, ammonia, or methane. When we leave the Oort cloud, we are 1 and 2 light years from the Sun. All this little world, which seems so big to us already, is located in an arm of the Milky Way. Our solar system is currently located in the Orion arm, one of the minor spiral arms of the Milky Way. The Orion arm is so named because of its proximity to the constellation Orion. Its length is estimated at around 10,000 light years, and its width at 3,500 light years. In this arm, the solar system is close to the inner edge in the local bubble, around 27,000 light years from the galactic center. The local bubble is a region a few hundred light years across, within which the solar system lies. It is thought to have entered this region 5 million years ago. It is thought to be the result of a series of supernova explosions a few million years ago. It is shaped like an hourglass with the solar system in one of its lobes. But the local bubble, unlike a soap bubble, is not empty. You know this because it contains the entire solar system. The solar system is also inside another envelope called the local interstellar cloud, or local plush. This is a very diffuse cloud, but its molecular temperature is roughly equal to that of the sun's surface, i.e. 6,000 degrees Celsius or 10,800 degrees Fahrenheit. It is about 30 light years across. The solar system is currently moving through it and is expected to exit within 10,000 to 20,000 years. The cloud was formed where the local bubble and another bubble, that of Loop 1, meet. Its density is very low, even though it is twice the gas density of the local bubble. The local cloud's potential influences on Earth are countered by the solar wind and magnetic field. As we saw before, the solar system circles the galaxy in 250 million years. But at the same time, it oscillates on either side of the galactic plane with a period of 66 million years. It crosses this plane every 33 million years. The solar system is not isolated. Its nearest neighbor is the Alpha Centauri system. This star system is only about 4 light years from our sun. Come on, I'll take you there. It's a system of 3 stars and at least 1 exoplanet. Alpha Centauri A and Alpha Centauri B are 2 stars that form a double star, very similar to the Sun. They are so close together that you need a very powerful telescope to distinguish them. They revolve around a common virtual center, the barycenter, in around 80 years. The 3rd star in this system is Alpha Centauri C, or Proxima Centauri, discovered only in 1915. It's a red dwarf, one of the smallest and least hot stars in the universe, but with a long life expectancy. It is the closest star to the Sun, but shines 20,000 times less brightly than the Sun. It is therefore invisible to the naked eye from Earth. Proxima Centauri b is an Earth-like exoplanet in orbit around Alpha Centauri b. It is located in the temperate zone of the solar system. It is located in the temperate zone of its star and is therefore potentially habitable. Let's stay a while in the local cloud. Other nearby stars include Sirius, Vega, Fomalhaut, and Arcturus. Sirius is the main star of the Big Dog constellation. Seen from Earth, it is the brightest star after the Sun, and therefore one of the most studied by astronomers. It is one of the white stars. It is 1.8 times larger than the Sun and 2.3 times more massive. It is accompanied by Sirius B, a small discrete white dwarf that is difficult to observe. Vega is the brightest star in the Lyra constellation. It is the 5th brightest star as seen from Earth. It is 25 light-years from the Sun. It is a spectral-type star, white tinged with blue, whose core hydrogen is transformed into helium by nuclear fusion. It is more massive than the Sun and is between 386 and 511 million years old. After leaving the main sequence, it becomes a red giant and then a white dwarf. It was the pole star in the 12th millennium BC and will be again in 12,000 years' time. The existence of at least one exoplanet in orbit around it is assumed. Let's move on to Fomalhaut. This is the brightest star in the constellation Pisces, and the 17th brightest in the night sky. It's a white star about 25 light-years from the Sun. It's twice as big and massive as the Sun, and 17 times brighter. I hope you brought your sunglasses. Fomalhaut B is a planet orbiting the star Fomalhaut A. It was the first exoplanet to be detected by optical photography, thanks to the Hubble Space Telescope in 2008. It is probably a gas giant. Let's look at Arcturus for a moment. It's the main star of the constellation Bouvier. It's the 3rd brightest star in the night sky, and you'll recognize it by its slightly reddish light. It's a red giant at the end of its life, with a mass close to that of the Sun, but a diameter 25 times greater. Let's move on to the center of the Milky Way, called the bulge. As I told you at the start of our journey, at the center of every galaxy is a supermassive black hole. The most massive black holes are found at the center of elliptical galaxies. As the Milky Way is a spiral galaxy, its black hole is relatively light, 4 million solar masses. Some can reach billions of solar masses. Black holes absorb everything that passes close by, the limit of no return being called the event horizon. A black hole is created after the death of a very massive star. The star's core collapses in on itself, causing the outer layers of the star to be expelled in a gigantic explosion called a supernova. All the remaining matter is concentrated in a small point called a singularity. The gravity of a black hole is so strong that it even traps light. I won't take you inside the horizon because we won't be able to get out or continue our journey. The horizon for the Milky Way black hole is 1/10 the distance from the Earth to the Sun. The rotation period at this distance is of the order of 6 minutes. The temperature of the horizon is very high. Gases entering a black hole can reach millions of degrees. On the other hand, it's very cold inside the black hole. The temperature of stellar black holes approaches minus 273 degrees Celsius, or minus 460 degrees Fahrenheit. Supermassive black holes are even colder. The more massive the black hole, the colder it gets. Our galaxy's black hole, discovered in the constellation Sagittarius, is naturally named Sagittarius A. At 13 billion years old, it is considered a dormant black hole, having swallowed up everything within its reach. The stellar objects orbiting it are too far away, beyond the horizon, to be absorbed. Researchers have discovered, however, that 200 years ago, it came out of its torpor to gobble up the gas and dust that passed close to it, for several months at a time. It was then at least 1 million times brighter than it is today. This light doesn't come from the black hole itself, since nothing escapes, not even light. It is produced by matter, which as it approaches the horizon, swirls and heats up before being swallowed up. It is this bubbling that produces light. It's the intensity of this light that tells researchers that a black hole is active and having lunch. Some researchers believe that Sagittarius A is not the only black hole at the center of our galaxy. They have discovered the presence of a compact cluster of stars near the central black hole. This cluster would have a mass of at least 1,000 solar masses, but given its small size, it can't contain only stars. Its mass would therefore contain an intermediate black hole. You know that a black hole is invisible, but that you can spot it by the commotion around it. Black holes are often accompanied by an accretion disk, the stars, dust, and jets that swirl around it. This is what we see in the images, and what allows us to tell that there is a black hole in the observed location. Astronomers have spotted numerous stars around Sagittarius A. By scrutinizing their orbits, they have been able to give a precise estimate of its mass and size. Its mass is 4.3 million times that of the Sun, but it is contained within a small space, 31 times the Sun's diameter. Around 50 stars revolve around the mouth of Sagittarius A without being swallowed. Yet, astronomers have combined 4 telescopes to observe this with such precision. The result is an interferometer called Gravity, which went into operation in 2016. But our black hole is a little prankster. Black hole specialist Daryl Haggard and her team reviewed 15 years of data to conclude that Sagittarius A is unstable from one day to the next and unpredictable over the long term. It releases random bursts of X-rays and radio waves, which disturb its surroundings. Whether these energetic bursts originate from distortions of the magnetic field or from bodies torn apart by the black hole remains unclear. All these reactions have long made it difficult for researchers to capture our black hole on film. The first image of the black hole was revealed in 2022, thanks to the Event Horizon Telescope, a network of 11 radio telescopes around the world. It shows the shadow of the black hole, a silhouette defined by the luminous cloud of gas trailing around it. Analysis of the various images collected has revealed the size of the black hole's horizon. It is thought to have a diameter of 60 million kilometers. Scientists believe that supermassive black holes originate from the merging of several black holes, but this hypothesis remains to be verified. Are black holes eternal, you ask? Scientists believe that black holes will disappear as they evaporate. Their mass will decrease over time, their temperature will rise, and so will the rate of evaporation. But this won't happen for billions of years. Let's move on from the center of the Milky Way to its so-called arms. Our galaxy is made up of 4 major spiral arms. The first is the Perseus arm, the major arm furthest from the bulge. As you might guess, it's close to the constellation of Perseus. It lies between the Cygnus and Sagittarius arms. But where do these arms come from? In the 1960s, 2 researchers at the Massachusetts Institute of Technology proposed a rather complicated theory known as density waves. Spiral arms are bumps of density waves where stars accumulate. These are the star jams I told you about at the start of our journey. The orbits of stars in a galaxy are not regular. They form ellipses that don't close in on themselves. This shift in the ellipses is due to galactic density waves and creates the spiral shapes of the arms. As you can see, these arms are luminous, containing thousands of stars, many of them young. They also contain the interstellar matter in which stars are formed. But in addition, all the stars in the galactic disk sometimes cross the arms, contributing to their visibility by increasing their luminosity. Thanks to the Gaia mission, we know more about stars than spiral arms. Gaia is an astrometric mission dedicated to measuring the position, distance, and motion of celestial objects, including stars. The Gaia satellite was launched in December 2013 for 5 years, but the mission has now been extended until 2025. The data collected should improve our knowledge of the structure, formation, and evolution of the Milky Way. The results obtained are published in the Gaia catalog, which is updated regularly. But let's take a closer look at the Perseus arm. It contains stars, of course, but also other objects listed in the Messier catalog. The Crab Nebula, for example, owes its name to its crab-like shape. By definition, a nebula is a celestial object composed of rarefied gas, plasma, and stellar dust. The dust scatters light in all directions, giving nebulae their beautiful colors. There are several types of nebula, and the Crab Nebula is one of the supernova remnants. These are very large nebulae, formed by the implosion of a dying supermassive star or the explosion of a white dwarf. Their lifespan is fairly short. The Crab Nebula lies 6,300 light-years from Earth, and is currently around 11 light-years across. It was first spotted by Chinese astronomers in July 1054 when it exploded. It is fascinating to observe, with its beautiful blue color and pulsar spinning on itself 30 times per second. It changes regularly, expanding at a rate of 1,500 kilometers per second, or 930 miles per second. The pulsar is made up of supernova remnants and radiates as much energy as 200,000 suns. A pulsar is a neutron star spinning very rapidly on itself, emitting strong electromagnetic radiation. A pulsar is the result of the explosion of a massive star at the end of its life, so it can be described as the corpse of a star, but it emits radio waves that enable it to be detected. As the first object in the Messier catalog I mentioned a moment ago. It is therefore also called M1. Its filaments are made up of ionized helium and hydrogen, as well as carbon, oxygen, nitrogen, iron, neon, and sulfur. The Crab Nebula is not only beautiful to observe, but also very useful to researchers, as numerous objects such as the Moon and planets regularly pass in front of it. Scientists take advantage of these transits to take measurements and refine their knowledge. It was Saturn's passage past the nebula in 2003 that enabled us to determine the thickness of Titan's atmosphere. The Perseus arm also contains open clusters known as M36, M37, M38, M52, and M103. In astronomy, an open cluster is a stellar grouping of around 100 to 10,000 stars of the same age, gravitationally bound together. Open clusters are not very luminous, and are mainly found in the Milky Way and nearby galaxies. Their life is fairly short, as their members eventually escape. This takes a few 100 million years. Take M36, for example. This is a young cluster only 25 million years old, made up of around 60 stars, a number of which have been shown by spectra to be rotating very rapidly. It is located 4,000 light-years from Earth. Now let's turn our attention to its neighbor M37, located at the same distance from Earth. Compared to its neighbors M36 and M38, it is the brightest. It also contains the most stars, possibly as many as 500, including a dozen red giants, to give the cluster an age. It is thought to be 347 million years old. Not bad for something with a limited lifespan, eh? Its other neighbor, M38, is said to be 290 million years old. It presents two curiosities. It is home to a yellow giant, 900 times brighter than the Sun. It lies very close to another, smaller and fainter cluster of around 40 stars called NGC 1907. All three are located in the constellation of the Kocher. A little further on, you'll find the open cluster M52, located in the constellation Cassiopeia. We don't know exactly how far it is from the solar system, but we do know that it contains around 100 stars and is 35 million years old. In the same constellation, we can also observe M103, which contains around 40 stars. It lies some 8,500 light-years from the solar system, approaching it at a speed of 37 kilometers per second. Let's move on from the Perseus arm to visit a second major arm of the Milky Way, the Sagittarius arm, or Sagittarius Carinae. This is the second major arm from the outside of our spiral, and one of the two longest. It lies between the Echo Croy arm and the Orion arm. It's divided into two parts. The one emerging from the central arm is called the Sagittarius arm, while its outermost part is called the Carina arm. It's a fairly dense arm, containing several clusters of different types, as well as nebulae. Let's discover them together. I've already told you about open clusters, but there are also globular clusters. You'll find both in the Sagittarius arm. Let's take a closer look at the globular cluster M55. A globular cluster is very dense, typically containing around 100,000 stars distributed in a sphere, ranging in size from 20 to a few hundred light-years. Its density is therefore much higher than that of an open cluster. The stars in these clusters are mainly red giants, so they are very old. They dot the halo of our galaxy, bringing together stars with strong gravitational links. To date, 150 globular clusters have been counted in our galaxy. M55 is a large globular cluster, around 110 light-years across, containing some 100,000 stars. As it's twice as old as the Sun, we can learn more about the very first population of stars. You'll also find open clusters in the Sagittarius arm, such as M21, M24, M26, and M11, nicknamed the Wild Duck Cluster. The latter is the richest open cluster in the Messier catalog, containing over 3,000 stars. The Sagittarius arm is also home to some interesting nebulae, so let's take a look. Let's start with the Eagle Nebula, home to the M16 open cluster and the famous Pillars of Creation. It's an emission nebula, meaning it's made up of clouds of ionized gas that absorb light from a nearby hot star and reflect it back in a variety of colors. This star nursery is located 7,000 light-years away. One of the places where new stars are created is called the Pillars of Creation. These are pillar-shaped clouds of dust and gas, not unlike those found in caves. As we continue our walk, we also come across the Trifid Nebula, also known as the Clover Nebula and the Lagoon Nebula. They're both nearby and easy to observe with binoculars in a summer sky. The first, the Clover Nebula, is the smallest, but of rare beauty. It has 3 zones: an emission zone, a reflection zone, and even an absorption zone. At its center is an emission nebula, i.e. clouds of ionized gas. These clouds, composed of 90% hydrogen, condense in many places to give rise to new stars. All this activity combined with the hydrogen produces red light. The hydrogen atoms in the cloud are not ionized, so the light is scattered by reflection. The result is a lovely blue color. To add further detail to this work, there are bands of compact dust and gas that form a cloverleaf shape at the heart of the nebula. These are known as absorption nebulae or dark nebulae. The size of the nebula is estimated at 40 light-years, but it is known to be close to the bulge of the Milky Way. Its neighbor, the Lagoon Nebula, lies in a very crowded part of our galaxy. This nebula is very large, about 110 light-years across. It lies 5,200 light-years from Earth. The brightest region of this nebula contains a special object called the Hourglass Nebula. A nebula within a nebula? Yes, it's possible. The Hourglass is a planetary nebula, the result of the liberation of the outer layers of a solar-type star at the end of its life. The resulting white dwarf can be seen at its center. Let me introduce you to one last nebula in the Sagittarius arm. They're so beautiful you just can't get enough of them. Let's take a look at the Omega Nebula, also known as the Swan Nebula, the Horseshoe Nebula, or the Lobster Nebula. Everyone sees something different. It's an emission nebula around 5,500 light-years away, with a diameter of 15 light-years. At its heart is an open cluster of some 30 rather young stars, which radiate the surrounding gas. We can now emerge from the Sagittarius arm and head towards the third major arm of our galaxy, the Echo-Croy arm, also known as the Centaur arm. We meet it before the Ruler arm. It's a very long arm made up of 2 sections. The one closest to the bulge is called the Echo arm, which becomes the cross arm as we move away from the center. The region where the Centaur arm crosses the central bulge is rich in newborn stars. In 2006, researchers discovered a large cluster of young stars containing 14 red supergiants. The following year, they discovered another cluster just a few light-years away. It contains around 50,000 newly formed stars, including 26 supergiants. We now come to the Ruler arm, also known as the Swan arm, which is a little more tenuous than the previous 3. Like the Sagittarius Carina arm, this arm has its source at the end of the central bar. An extension of this arm was discovered in 2004, making it much longer than previously thought. The Milky Way also contains minor arms, which lie between the 4 main arms I've just mentioned. The best known is the Orion arm, which contains the solar system as we saw earlier. But the Orion arm, even smaller than the other arms, contains many objects. There are numerous clusters and nebulae, as well as a double star called Winnicky 4, located in the Big Dipper constellation. Nebulae include the Owl Nebula, a round planetary nebula in the Big Dipper constellation, Lyra Nebula, in the constellation of the same name, resembling a round cigar, the Dumbbell Nebula, in the constellation of the Little Fox. This was the first planetary nebula to be discovered. These three nebulae are planetary nebulae, so called because they were once mistaken for planets. They are large clouds of gas created by dying giant stars, which began to eject their upper layer. They disperse in 50,000 years or less. There's also the Orion Nebula, in the Orion constellation, of course. It looks like a bird spreading its wings, a delight for observers. The Pleiades cluster is located in the arm of Orion. Another cluster, you say? Yes, but this one's a bit special. It can be seen from both hemispheres of the Earth in the constellation of Taurus, but above all, it has been known and used since prehistoric times. Neolithic priests and shamans already attached extreme importance to this cluster, since its appearance in the northern hemisphere corresponded to the beginning of the harvest. In Polynesia, the Pleiades appear around November 20th, heralding the season of plenty. This group of stars played an important role in the establishment of ancient calendars, from India to the ancient Greeks. To date, there are around 3,000 stars in this cluster, a dozen of which are visible to the naked eye. Its density is relatively low compared with other open clusters, extending over an area 4 times the diameter of the Moon. There are 17 clusters in Orion's arm. Let's move on from this bright part of the Milky Way to the darker regions. Since the start of our journey, we've been dazzled by the starlight and the magnificent colors of the nebulae, but the Milky Way also has its darker spots. Let me introduce you to the Great Rift, or Dark Rift. It's a huge dark nebula that runs along Orion's arm. The Great Rift forms a dark band stretching over 1,000 light-years. It begins in the constellation Cygnus, where it is also known as the Cygnus Rift, and ends in the constellation Sagittarius. It also passes through the Eagle constellation and can be followed as far as the Ophiuchus constellation, where it widens. This nebula is a mixture of dust and molecules, largely composed of dihydrogen. The latter is the source of its darkness and opacity. It lies around 2,200 light-years away and contains 1 million solar masses of gas. If you want to observe it from Earth, you'll be able to do so from midsummer until October. You can see dark areas between the arms of our galaxy. These are not places without stars, but areas where stars are obscured. They are hidden by gigantic clouds of dust that obscure the sky by absorbing the light that passes through them. This dust is mainly residue, the ashes scattered by supernova explosions. They are solid grains essentially made up of carbon, silicon, and oxygen, combined with hydrogen in the form of water ice. The rest of the dust is made up of grains of similar composition, but blown by the stellar winds of red giants. Earlier in our journey, I spoke to you briefly about exoplanets. Let's return to them for a moment. An exoplanet is a planet outside the solar system orbiting a star or brown dwarf. You may not know it, but a brown dwarf is neither a giant planet nor a small star. It's a celestial body somewhere in between. Unlike stars, which often die spectacularly, brown dwarfs cool down when they run out of fuel. First detected directly in 2004, the number of identified exoplanets continues to grow. Observation methods have evolved, and today we use a transit method. This involves observing a star continuously and measuring the decrease in brightness caused by the planet passing in front of it. Thanks to space telescopes like Kepler, astrophysicists have been able to estimate that between 5 and 10 billion Earth-like exoplanets are present in the Milky Way. Earth-like does not mean that humans live there like we do, but that the planet is close in size to our own and orbits its star every 237 to 500 days. They would be located in the habitability zone where liquid water could exist. All this remains to be verified, of course. Today, it's the Gaia mission that's continuing to research into the data provided by the Kepler mission. Analyses have also revealed that planets can form in multiple star systems, so you could see several sunsets at the same time. Exoplanets are very diverse. Like the planets in our solar system, they are classified into two groups, gaseous and telluric. Gaseous exoplanets are easier to spot because they are more voluminous. Their mass varies from 10 to 50 times that of the Earth. They can be Jovian or Neptunian. Jovians are composed mainly of hydrogen and helium, sometimes almost exclusively of helium. They are referred to as hot or cold Jupiters. Neptunians are ice giants, composed of water, methane, and ammonia. There are also hot and cold Neptunes. The latter are much further away from their star. Telluric exoplanets are harder to spot because they are smaller. Of the thousands of exoplanets on record, only around 500 are telluric planets. If their mass is between 1 and 10 times that of the Earth, they are called super-Earths. Let me introduce you to a few of them. Let's start with 51 Pegasus b, the first exoplanet to be discovered in 1995 by Michael Mayor and Didier Queloz. It's a hot Jupiter, 50 light-years from Earth, orbiting its yellow dwarf star in just over 4 days. It has a mass 150 times that of the Earth, and a temperature of 1,000 degrees Celsius, or 1,800 degrees Fahrenheit. Osiris, or HD 209458b, is also a hot Jupiter, quite similar to 51 Pegasus b. It was the first planet whose light was measured by direct detection in 2005. Let's turn our attention to TRES 4b, discovered in 2007 using the transit method. It's also the planet with the lowest known density, 0.23 grams per cubic centimeter. It lies in the constellation of Hercules, around 1,400 light-years from the solar system. Its star, 3 to 4 times brighter than the Sun, has used up all its hydrogen and begun to transform into a red giant. The first confirmed rocky exoplanet in 2009 was Korot 7b. It orbits its star, an orange dwarf smaller than the Sun, in 20 hours. Its surface temperature exceeds 2,000 degrees Celsius, or 3,600 degrees Fahrenheit in places. Its density is close to that of the Earth, suggesting that it is indeed a rocky planet, a super-Earth. It has a sister planet, Korot 7c, whose mass is around 8 times that of the Earth. As you can see, every object in the galaxy is different from its neighbor and deserves a detour, but that would be a never-ending journey. Before continuing our journey, let me tell you about one more exoplanet. This is WASP 193b, which scientists compare to cotton candy. It intrigues them because it doesn't fit any conventional model. Its density is as low as that of cotton candy. It's a gas giant 1.5 times larger than Jupiter, but with a featherweight 1/10 the mass of our giant. It is the second lightest planet in the current catalog, just behind Kepler 51d. It enters the class of swollen Jupiters. What a funny name. Located 1,200 light-years from Earth, WASP 193b orbits just 10.1 million kilometers from its star. It takes 6.2 Earth days to orbit it. Researchers speculate that it is composed mainly of the very light gases helium and hydrogen. Its inflated appearance is thought to be the result of radiation emitted by its nearby star. So far, it defies all known theories of planet formation. Interesting, isn't it? We've traveled a long way inside the Milky Way, but you certainly want to get closer to its edges, its limits. Let's have a look. I've already told you that the Milky Way belongs to a much larger hole called Laniakea. This superstructure is made up of filaments bordered by vast zones of empty space. Our galaxy lies in one of these filaments, so it's bordered by empty space on one side and numerous other galaxies on the other. The filaments are connected to each other by intersecting zones that are home to galaxy superclusters. These filaments of galaxies travel at a speed of 600 kilometers per second, or 370 miles per second, towards a region of space known as the Great Attractor. By migrating in this way, in the same direction, galaxies create denser zones and leave behind zones of emptiness. In 2019, a team of researchers mapped an immense empty zone bordering the Milky Way, known as the local void. Its existence has been known since 1987, but it was difficult to study as it is located behind the galactic obscuration zone, i.e., behind the dust cluster in the central regions of the Milky Way. Scientists therefore analyzed the motion of 18,000 galaxies around our own as part of the Cosmic Flow program. The results show that this empty space continues to empty. Matter is continuously evacuated from this region, which becomes emptier and emptier as it expands. The void is thought to measure around 200 million light-years, 2,000 times larger than the Milky Way. The Cosmic Flow program explores not only the structure of our local void, but also its relationship with the giant voids that surround it. The Hercules void, the Sculptor's void, and the Eridan void, which are much better known because they lie outside the galactic obscuration zone. But they're not on the agenda for our expedition. Let's get back to our local void. Of course, as you'll have gathered, this place isn't as empty as an empty box. It's simply a less dense zone of the universe. But its study is of great interest. Most of the matter that constitutes us must come from this void, which therefore plays a role in our galactic archaeology. Faint filaments of galaxies run right through the local void. Understanding the 3D structure of the local void allows us to re-examine the question of our speed in the universe. The repulsive thrust of the local void, combined with the gravitational attraction to the high density of galaxies on its opposite side, partly explains the mysteriously high speed of our galaxy. According to the researchers, the Milky Way and Andromeda galaxies currently lie in the green valley of the color magnitude diagram of galaxies. This diagram shows the relationship between the absolute magnitude, luminosity, and mass of galaxies. The diagram comprises 3 zones: the blue cloud, containing mainly spiral galaxies, the red sequence, containing mainly elliptical galaxies, the green valley, which lies between the two and includes a number of red spiral galaxies. The green valley is populated by galaxies in transit between the blue cloud, where stars are regularly created, and the red sequence, where galaxies no longer create stars. In this region, the gas needed to make stars is less and less present. The Milky Way is still very active in star creation, but numerical simulations indicate that star formation in our galaxy will cease within 5 billion years. The galaxy is currently moving towards the Great Attractor. It's heading towards it, but also towards other galaxy clusters, including the Shapley supercluster. This is a supercluster of galaxies located in the constellation Centauri, 650 million light-years from the Milky Way. At the same time, the Andromeda galaxy, 2.5 million light-years away, is approaching the Milky Way at a speed of 300 kilometers per second, or 185 miles per second. The 2 galaxies are expected to collide. The 2 galaxies are expected to collide within 4 billion years, unless other celestial objects alter their course. The 2 galaxies will collide head-on and then pass through each other, leaving trails of stars and gas in their wake. For millions of years, the 2 galaxies will continue to move closer together, then further apart, mixing their stars and redrawing their constellations. Finally, after 1 billion years, they will merge to form an elliptical galaxy, or an immense disk galaxy. By this time, the Sun will have begun its transformation into a red giant, and the Earth will no longer be habitable. It and the stars will be propelled into new orbits, on the bangs of the new galaxy. What's left of the solar system will have a new cosmic home, a giant oval galaxy. This new galaxy already has a name, Milkomeda. It's the name given to it by the astrophysicist who simulated the collision of the 2 galaxies, Avi Loeb. Scientists predict a dazzling spectacle full of cosmic lights. How can we be so sure of this collision? Numerous researchers have made calculations based on galaxy speeds and trajectories. The Hubble telescope team has been making extremely precise observations of Andromeda's lateral displacement for 6 years. They leave no doubt about this future collision. Our fabulous journey ends here. The Milky Way is a magnificent, gigantic system traveling through space at dizzying speed. When you look up at the sky, all the stars you see belong to this galaxy. The Milky Way, 13.6 billion years old, contains 300 to 400 billion stars, more than 160 clusters, around 3,000 planetary nebulae, and over 100 billion planets. Every year, on average, 2 new planetary nebulae appear in our galaxy. This is enormous, and even more impressive when you consider that our galaxy is one of the 2,000 billion galaxies in the observable universe. Our galaxy is almost as old as the universe, so it has a lot to tell. Astronomers began gathering knowledge about it very early on, since it has been visible to the naked eye and spotted since prehistoric times. Some of this knowledge has been verified, but there are still mysteries and uncertainties. As always in astronomy, each discovery raises new questions. The evolution of observation instruments allows us to spot celestial objects from further and further away. But before we enter our hibernation chambers and drift off into a deep sleep, let's take a closer look at one of Saturn's moons. Behold Titan, the only known cosmic object to exhibit a stable liquid surface mass. This feature, though extraordinary, is not the only one this satellite possesses. Even more disconcerting, near its north pole, in Titan's second largest sea, called Ligeia Mare, a luminous object seems to be playing hide-and-seek. Sometimes visible, sometimes nowhere to be seen, unlike its direct vicinity, this zone was explored as early as 2004 by NASA's Cassini probe. But it was in July 2013 that it was first spotted in images from the same probe, before disappearing again a few days later. The area, estimated at around 260 square kilometers, or 160 square miles, finally reappeared in images dating from August 2014. To everyone's surprise, its appearance was different from that observed 2 years earlier. Is it an object floating on the surface of the sea, which for some unknown reason remains static? Or is it simply a change in the landscape, suggesting the presence of dynamic geological mechanisms in Titan's atmosphere? Researchers have put forward several hypotheses about the nature of this strange island. It could be caused by waves linked to an atmospheric phenomenon, or it could be composed of gas bubbles emanating from the depths of this liquid expanse. The appearance could also be explained by the formation of methane ice, or even an increased concentration of suspended particles, such as silt floating between two levels of water. But for some scientists, these extraordinary changes on the moon's surface are akin to the seasonal changes on Earth. Indeed, they have noticed that this mysterious island has always revealed itself at the beginning of summer in the northern hemisphere. It could, therefore, be linked to seasonal events, but over a longer period than our 4 seasons. As you can see, it's not only nature on Earth that has some surprises in store for us. This discovery, like a waking dream, brings us back to our collective phantasm, finding another habitable planet. Our sidereal journey now takes us to a strangely dark area of space. I invite you to step out of your chamber and let yourself be absorbed by this strange universe, virtually devoid of any visible matter. Faced with this enveloping, even deafening blackness, the surprise is total. Here you are in the middle of nothing, or almost nothing. But don't panic. Don't let this frightening environment overwhelm you. We're not sinking into an endless cosmic hole. Although space seems to be dotted all over with objects of varying luminosity, there are a few vast places where, strangely enough, emptiness dominates. We're currently right in the middle of one of them. It's the local hole, also known as the Keenan-Barger-Cowie Void, or KBC Void. This structure, or local subdensity, is no more and no less than a vast expanse, where matter has a density around 20% lower than the average of the observable universe. Studied in 2013 by 3 astronomers, the local hole closely resembles a sphere, around 2 billion light-years in diameter. And I'm going to surprise you. This cosmic void isn't as empty as it looks. I could even say that your cosmic address depends on it. In fact, it contains most of the Laniakea supercluster, including the local group, and consequently, the Milky Way. Our Sun is only a few hundred million light-years from the center of the local hole. Here's another piece of information that's sure to baffle you. Cosmic voids like this one exist in dozens of other, less exceptional dimensions. The only cosmic void larger than the local hole is nearly 3 billion light-years across. Thus, when observed on a very large scale, the universe resembles a cheese of holes, with zones rich in matter and others largely empty. Our galaxy and its wider neighborhood are therefore evolving in an immense empty bubble. According to the cosmological principle, the distribution of matter throughout the universe is fairly homogeneous, even over vast observed areas. While this can be confirmed on scales of around 250 million light-years, when we look at even larger regions, these cosmic holes appear. But what's even more interesting is that these voids could explain the discrepancy in Hubble constant measurements. Indeed, depending on the observational methods used, the expansion velocity of the universe presents contradictory values, known as the Hubble tension. The velocities of thousands of galaxies just located and counted were found to be 10% higher than those predicted by the lambda cold dark matter model. Makes you wonder whether the standard lambda cosmology model is really reliable, doesn't it? Could it be that unknown forces or manifestations are influencing our universe? This could explain why the model's predictions turned out to be wrong after these observations. The KBC vacuum is therefore a density anomaly, which, in addition to challenging our current understanding of the dynamics of our universe, could provide the beginnings of an explanation for some major inconsistencies. Scientists at the University of St. Andrews recently put forward a hypothesis. The velocity fluxes of galaxies, i.e., the speed at which they move as a group across the universe, would naturally be higher in and near this cosmic void, rather than in constant acceleration. They suggest that galaxies located within, or relatively close to this void, would exhibit higher velocities due to differences in matter density and consequently discordant gravitational forces. In short, local variations in the expansion rate of the universe would be related to Newton's laws of gravity, which are supposed to apply uniformly throughout the universe. Thus, according to their theory of modified Newtonian dynamics, MOND, regions similar to this void would experience a weaker gravitational force, resulting in greater velocity. If this explanation proves relevant, in addition to challenging the foundations of gravity theory, it could mark the beginning of a new age in cosmological research. Your hibernation chamber, programmed to bring you gently back to a state of wakefulness, has just opened. Your eyes are immediately drawn outwards by countless luminous galactic filaments. Here we are, close to the largest superstructure in the universe known to date. You're looking at the Great Wall of Hercules' Crown Borealis, also known as the Great Wall of Hercules' Corona Borealis. This gigantic group of galaxies lies around 10 million light-years from our Sun in the constellation of Hercules and Corona Borealis, as its name suggests. Its discovery, which dates back only to November 2013, can be explained in part by its remoteness. Scientists spotted it by mapping gamma-ray bursts, the dazzling explosions of the most powerful stars in the cosmos, far away and massive. But they had to be patient. Indeed, these explosions, which release more energy in less than 1/10 of a second than our Sun will produce in its entire existence, are extremely rare. In an ordinary galaxy, explosions of this type occur only exceptionally, at the rate of one every few million years. The stars that cause these cataclysms are very massive, requiring large quantities of matter for their formation. If these explosions can be used to pinpoint a galaxy or a large body of matter, they need to be the subject of lengthy study, involving the recording of colossal quantities of data. This is what astronomers set out to do, mapping these luminous phenomena from 1997 to 2012. To do this, they used the Fermi and Swift robotic satellites. The latter were designed to detect gamma-ray bursts by measuring their redshifts. The study of the data collected paid off. The map drawn up over 15 years of observation revealed 14 gamma-ray bursts with redshifts. What's more, these similar explosions were very close together. For scientists, there can be no doubt. This far-flung region of space is home to a very large group of galaxies and large quantities of matter bound together by gravity. According to their estimates, this structure, home to billions of galaxies, seems to measure 10 by 7.2 billion light-years. However, while it covers just over 10% of the diameter of the observable universe, it is only 900 million light-years thick. Until now, the largest observable structure in the universe was represented by the group of large quasars, measuring 4 billion light-years. To give you a better idea of these unusual dimensions, remember, our galaxy, the Milky Way, measures just 100,000 light-years in diameter and is only 2.5 million light-years away from its nearest neighbor, the Andromeda Galaxy. But how does this discovery fit in with the list of space anomalies? To cut a long story short, the Great Wall of Hercules' Corona Borealis doesn't fit in with the principle of cosmology, Albert Einstein's famous theory mentioned earlier. According to this principle, the entire universe is isotropic. Cosmology therefore stipulates that the universe is the same in all directions, spatially homogeneous, and similar at every point on a scale of several hundred million light-years. Thus, scientists who assume that matter has been evenly distributed since the creation of the universe predicted that no structure could be larger than 1.2 billion light-years. However, the Great Wall of Hercules' Corona Borealis is 8 times larger than this supposed limit, calling this cosmological principle into question. What's more, this imposing structure contradicts theories on the evolution of our universe. This glittering wall you can admire is some 10 billion light-years away from our Earth. This means that terrestrial observers have seen this structure as it existed 10 billion years ago. The famous Big Bang at the origin of our universe occurred 13.8 billion years ago. This difference is far too short. How could such a gigantic structure have formed in just 3.8 billion years? The existence of such a structure remains a mystery to astrophysicists. With their current understanding, they are unable to explain how it could have formed in such a short space of time. The Great Wall of Hercules, Corona Borealis, could well compromise the veracity of the Big Bang theory. As their discoveries continue, astrophysicists are constantly adding to their list of enigmas to be solved. One of them is to explain the presence of rings around objects that shouldn't have them. As a reminder, only Saturn, Jupiter, Uranus, and Neptune, the giant planets, were equipped with these attributes in our solar system until this unexpected discovery. Introducing Chariklo, an asteroid discovered in 1997 that orbits more than 2 billion kilometers, or 1.2 billion miles beyond Saturn's orbit, deep in our solar system. While it is the largest member of the Centaur asteroid class, with a diameter of 302 kilometers, or 188 miles, it has been favored by many observers since 2013 for its astonishing peculiarity. This asteroid, around 50 times smaller than the Earth, has 2 rings. See how dense and narrow they are. Estimated at just 5 kilometers or 3 miles wide, they orbit at an estimated distance of 400 kilometers or 250 miles from the primary object. It is the smallest celestial body encircled by rings discovered to date. But it's not the only one. In 2017, a second such discovery was announced, this time concerning a small planet in the Kuiper Belt. Look at this piece of rock showing off its rugby ball appearance. It's Haumea, a dwarf planet averaging 6.5 billion kilometers, or 4 billion miles from our Sun. While trying to determine the size of this object, detected in 2004, astronomers discovered its particularly dense equatorial dust ring. No fewer than 12 telescopes pointed their lenses in Haumea's direction as it passed in front of a star, the ultimate condition for determining its dimensions. But to the great surprise of the researchers, a rapid extinction preceded the passage of this dwarf planet in front of the luminous star. They were able to establish that this dwarf planet, with a diameter approaching 2,000 kilometers, or 1,300 miles, is surrounded by a fairly narrow ring, around 70 kilometers, or 44 miles, but particularly dense, which orbits it at a distance of around 1,000 kilometers, or 620 miles. No explanation has yet been found for the origin of this ring. Is it an ephemeral phenomenon, or is it long-lasting? What is certain is that this anomaly could indicate that rings surrounding dwarf planets may not be as rare as scientists previously thought. In fact, An even more sensational discovery was made in the following years. This time, a ring was detected near an even more distant trans-Neptunian object. Meet Quaoar, a dwarf planet whose ring is not only unpredictable but also curiously located, hence its late discovery. In fact, Quaoar was discovered in 2002, while its ring was only recently detected and revealed to the public in February 2023. Quaoar was discovered by a team of American astronomers during Caltech's large-scale sky survey. As they surveyed the Kuiper belt for the brightest objects, their attention was caught by a dark object of apparent magnitude 18.6. It was moving slowly in relation to its background, a cloud of distant stars. Scientists call this phenomenon occultation. Its diameter, quickly estimated using data from the Hubble Space Telescope, is around 1,110 kilometers, or 690 miles, giving it the status of a dwarf planet. It is also one of the largest objects in the Kuiper belt. In addition to its size, this dwarf planet has a satellite. It's a moon, about 170 kilometers or 105 miles, called Wewat. But what's even more incredible is that this small planet, which orbits our sun at a distance equivalent to 43 times that separating the Earth from the Sun, is surrounded by an extraordinarily distant ring. With a radius of 4,100 kilometers or 2,600 miles, it lies well beyond the Roche limit, defying previous models for the formation of such a structure. No other ring has ever been detected so far from its planet. This one is more than 7 times its radius, marking the boundary of the Roche limit. According to this model, a ring could not exist beyond 2 to 3 times the radius of the central body. This discovery is an anomaly for scientists, running counter to the above-mentioned model, whose origin lies with astronomer Edouard Roche. The rings are not supposed to exist in such a remote perimeter. The particles of matter present in this zone should have agglomerated with each other, since they are not subject to the tidal effects produced by the main body, which are greater than the gravitational cohesion forces taking place between them. And yet, despite being outside the Roche boundary, these numerous pieces of debris don't seem to be undergoing this long agglomeration process at all. So how does such a ring manage to endure over time? Here's one more mystery for astrophysicists. The icy temperature of the ring's debris could provide the beginnings of an explanation. Some scientists believe that the ice particles undergo so-called elastic collisions, preventing them from sticking together. So what you have before you is an exceptional, unusual, even inexplicable ring, at least for the time being. Admittedly, it doesn't have the splendor or grandeur of Saturn's rings. Nevertheless, its position in relation to Quaoar makes it unique, especially as it hides the secret of its very existence for the time being. But how about a little rest? After observing these anomalies, each more disconcerting than the last, a good night's sleep will enable us to tackle the next stage of our exploration with slightly clearer skies. The next time we wake up, a new surprise awaits you. Look at this exceptional star. This is Tabby's star, one of the most mysterious and exciting stars in the Milky Way, just 1,470 light-years from our Sun, Tabby's star, which cohabits in the constellation Cygnus alongside numerous other luminous objects, stands out from its companions in a singular way. Although first detected in 1890, Tabby's star has been the subject of particularly close study in recent years. The reason for this is its unusual light fluctuations. While the Kepler Space Telescope recorded variations in the brightness of over 100,000 stars in the Cygnus and Lyra constellations, data collected between 2009 and 2013 led astronomers to take a closer look at this star. For scientists searching for exoplanets, the brightness fluctuations recorded are unmistakable. There is probably a large mass, or many small masses in close formation, in its vicinity. This is why there is so much interest in this star, potentially accompanied by an exoplanet. Observations show that the star displays an atypical light curve for a number of reasons. It shows both periods of deep decline and long-term changes. On several occasions, its brightness has declined to as much as 22% of normal. What's more, a study of the archives revealed that this seems to have been happening repeatedly over a number of years. Now, if a planet the size of Jupiter were to occult this star, not only would it lose no more than 1% of its brightness, but more importantly, these changes in brightness would be cyclical. Except that, in this case, the fluctuations are totally random. Scientists then speculated that it could be an occultation linked to a random phenomenon occurring between Tabby's star and the observation zone. But this hypothesis doesn't hold water, especially as periods of significant brightening have also been recorded. I'm not going to hide the fact that the idea of an extraterrestrial megastructure has occurred to a few followers of this dogma. A Dyson sphere set up by an alien civilization would then be able to appropriate some of this light to meet its energy needs. But this idea was dismissed as preposterous by most. In fact, as you can see, there's no sign of any unknown technology being installed. But then what could be blocking the light from this star during the darkening phases we've noticed? The most simplistic hypothesis suggests that irregular dust clouds or orbiting debris could explain this phenomenon. However, the researchers noted that the infrared wavelengths of light pass through the gradation more easily than the ultraviolet bands. For them, this observation rules out the possibility of a solid object. Could it be the debris of an exoplanet? Or an exolune torn apart by the star? Or could it be several groups of comets sailing alongside it, like swarms of bees? Or are they inherent fluctuations of the star itself, like the famous Betelgeuse? But in that case, why these versatile variabilities? Could it be that the star is undergoing a natural process that means it has reached a critical stage of phase transition? Whatever the case, in order to unravel this mystery, scientists need to be sure of one thing. If it's an interference due to the superposition of an occulting material, they'll have to confirm its circumstellar nature, and then its nature. If this is not the case, new alternative models for starlight could be developed. And what about you? What's your opinion on this anomaly? Just a stone's throw from this star with its strange behavior, we broach the subject of extraterrestrial entities. This must remind you of an unusual phenomenon you've probably heard of, still considered an anomaly for want of a plausible explanation. On October 19, 2017, a mysterious object was spotted as it passed through our solar system, baffling astrophysicists for many reasons, with some even considering the possibility of extraterrestrial technology coming to visit us. This fabulous object was detected by Hawaii's Pan-STARRS telescope and christened Oumuamua, scout or messenger in the Hawaiian language. Its hyperbolic trajectory and unusually high speed led to the conclusion that it came from another star system. Coming from who knows where, this bolide was the first interstellar object to visit us so closely, before continuing its long journey to an unknown destination. With its cigar-shaped ship-like appearance, it brought to mind certain cinematic images, often ominous. As you can imagine, this interastral intruder did not go unnoticed for a number of reasons. First of all, its dimensions. Measuring in length between 200 and 400 meters, or 600 and 1,300 feet, with a width 10 times less than its length. What's more, the object's brightness and variations in luminosity could lead observers to believe that it was a metallic object rotating on itself. Once again, science fiction films are full of spaceships based on similar movements. Its appearance wasn't the only thing that puzzled scientists. Its attitude proved just as disconcerting. While from a rational point of view, it resembled an asteroid or comet, it displayed neither the sparkling tail nor the halo usually attributed to the latter. Even more disconcerting was the way it crossed our solar system. When it was detected at a distance of around 30 million kilometers, or 19 million miles from the Earth, its speed was estimated at 50 kilometers per second, or 31 miles per second. Then, as it drew closer to our Sun, it accelerated progressively until it reached 87 kilometers per second, or 54 miles per second. But perhaps the strangest thing about it was its rocket-like behavior. Indeed, after orbiting the Sun, it experienced an extraordinary acceleration as it changed its trajectory. At that very moment, it was traveling at a speed of over 300,000 kilometers per hour, or 185,000 miles per hour, heading for the constellation of Pegasus, before finally exiting our solar system. Scientists theorize that such a brief visit by such a cosmic object could have been the result of a spacecraft. Could it have been a simple asteroid, an atypical comet, a hydrogen iceberg, or the debris of an exoplanet? Naturally, researchers tried to unravel this mystery by mining the data collected, specifically those concerning this fabulous acceleration coupled with an improbable change in its trajectory. Neither a gravitational kick from the Sun nor an outgassing phenomenon seem to explain this supernatural behavior, contrary to the laws of physics. What's more, no unusual radio emissions were detected during the same period. Since 2019, a study by the Astronomy Department of the University of Maryland has settled one point. The object did not originate from an alien entity, and its natural origins were justified. According to a study published in Nature magazine in March 2023, It is a water-rich object, similar to a comet that has undergone significant weathering. It reports that Oumuamua, like comets, is essentially composed of water and rock. The object would have been propelled far from its star's gravitational grip before drifting off into interstellar space. During its long cosmic wanderings, it would have been bombarded by cosmic rays, particularly energetic particles that can penetrate dozens of meters beneath the ice. According to one model, more than a quarter of the water molecules present on Oumuamua were transformed into molecular hydrogen, which was then trapped in countless small pockets of ice. When the object got close enough to our Sun, at a distance of tens of millions of kilometers or miles, the hydrogen ice would have undergone a sudden change of state, transforming into gas. By escaping on its own, the hydrogen gas would then have propelled Oumuamua, causing the abrupt change in direction observed. This hypothesis, which holds true for many scientists, helps explain why no halo or streak was detected by telescopes in 2017. The exact nature of Oumuamua cannot be certified to this day, leading, as you've seen, to major discrepancies in the sphere of astrophysicists. This object has definitely left our solar system, taking with it a mystery that will never be solved. However, future observations by the Vera Rubin telescope in Chile, due to begin in 2025, could well change all that. Designed to detect new comets, both inside and outside the solar system, it should be able to collect relevant data on them. If, like Oumuamua, the smallest comets show signs of releasing trapped hydrogen and do not display a characteristic tail, then the existence of this new type of comet could be confirmed. How about that? Our onboard computer reports that it has recorded a radio signal that seems to be repeating itself on a regular basis. Let's take a closer look. The transmission comes from the constellation of Sobieski's Shield, east of the tail of the serpent. The ground team confirms that they too have detected this unusual signal. They tell us they've observed the signal lasting from 30 seconds to 5 minutes, repeating itself strangely, slowly every 21 minutes. Our cross-reference data indicates that we are indeed interested in the same phenomenon. What could be behind such a radio source? Could it be an extraterrestrial radio signal? Of course it could. But let's not panic. This signal mustn't be perceived as a threat. Let me explain. This intriguing radio signal was first detected in 2022 by Australia's Murchison Wide-Field Array Radio Telescope, before being observed and then confirmed by numerous other facilities worldwide. In a study published in July 2023 in the journal Nature, researchers from Australia's Curtin University report their findings. Although they are not yet in a position to catalog the object perfectly, they do offer some explanations. It turns out that this extraterrestrial signal is emitted by an astral object named GPM J1839-10. Yes, you heard me right. It's coming from a star, not from an entity potentially in search of traces of distant life. However, this stellar object, which behaves like a pulsar or magnetar, and is located 15,000 light-years from Earth, has left scientists stunned. Radio signals from such stars, sweeping across our Earth on a regular basis, are nothing out of the ordinary, you may say. And yet, there's nothing coherent about this one. As you probably know, magnetars, or dying stars, produce energy at regular intervals. These neutron stars, with their extremely powerful magnetic fields, are particularly dense, rapidly rotating objects. The flashes they produce last only a few milliseconds, rarely more than a second or two, and are repeated at a steady rate of no more than a handful of minutes. In this particular case, let me remind you that the powerful radio beams detected last up to 5 minutes and are repeated only every 21 minutes, which is inexplicably slow for such an object. Such periodicity has never been observed before. Could it be that scientists have spotted an exotic object never before discovered? Subsequent study of the telescopic archives revealed another fact about these enigmatic radio wave emissions. The scientists, totally baffled, asserted that these have been recurring since at least 1988. This means that the star has been transmitting in this way for over 35 years. In January 2022, the discovery of a similar object, J1627-5235, was also announced. This transient object also emitted strong radio emissions lasting 60 seconds and recurring every 18 minutes. However, according to recent monitoring and archive data, its radioactivity was short-lived compared with that of its counterpart. It lasted just 3 months out of 8 years of observation. If it is indeed a magnetar, such a discovery calls into question current knowledge of this class of neutron stars. As they age, their magnetic fields gradually weaken, inevitably slowing down their rotational speed. Then, when they reach the death line, the threshold at which they can no longer produce high-energy emissions, they fall silent forever. In our case, however, this limit has been well exceeded. Nevertheless, this beam of radio waves continues to rotate, like a tireless cosmic beacon. Scientists believe that it could be an extraordinarily slow magnetar, or even a white dwarf radio pulsar, but one thing is certain. Even if one of these two hypotheses proves to be correct, both involve numerous parameters and uncertainties that remain to be elucidated. Let's add this new anomaly to the many other cosmic mysteries and continue our journey. Let's make sure everything's okay, shall we? What are you staring at? What are you saying? A curious circular mist? Yes, it is. Our radio wave measuring equipment is categorical. Straight ahead of us stands a strange ring of cosmic smoke. Its ghostly appearance partially obscures the stars in the background. If we were observing it through a telescope, I'd certainly advise you to clean your lens. A priori, this enormous structure, large enough to contain entire galaxies, is only detected in the radio range. None of our other measuring devices seem to perceive it. This reminds me of a recent discovery. I think we're looking at an odd radio circle, or ORC for the more erudite. The first such object was detected in 2019 by astronomer Anna Kapinska. When she presented this image to Ray Norris, a science professor at the University of Sydney in Australia, she named it WTF, for what the fuck, which shows just how disarming, even frightening, this discovery proved to be for her. Before publishing the result of this astounding discovery, the astronomers preferred to wait several months. In particular, they wanted to be sure that the signal detected was not an astronomical mirage that could be attributed to the measuring equipment. Further data collected by an Indian radio telescope confirmed this unusual discovery. No plausible explanation for this strange radio circle, which resembled a ball of smoke, could be found. For some, this puzzling phenomenon could be linked to a wormhole. For others, it could be the result of an explosion in a deep space galaxy, or a collision between a powerful neutron star and a black hole. Just a few days after this exceptional discovery, a second strange radio circle was detected, proving that this was not a unique case. To date, only 11 strange radio circles have been spotted, but researchers believe that thousands more could well be discovered in the not-too-distant future. However, observing them is proving very difficult. These structures, although colossal, with a diameter of several 100,000 light-years, 10 times wider than our own Milky Way, are billions of light-years away. What's more, as mentioned earlier, they emit light only at radio wavelengths. Since then, Ray Norris and his team have taken a very close look at the very first strange radio circle discovered. To do so, they used the Meerkat antenna array at the South African Radio Astronomy Observatory. With 64 domes, each measuring 13.5 meters, or 45 feet in diameter, this is the world's most sensitive and precise radio wave equipment. The anatomy of this foggy ball has been revealed to scientists, revealing itself to be far more complex than presumed. The spherical structure is made up of several intersecting arcs. Above all, at the very heart of this system, a tiny dot has been spotted. It is possible that this dot, which also appears in images taken at other wavelengths, is an immense elliptical galaxy. For the researchers, there's almost no doubt. These two elements, the strange radio circle and the galaxy, are linked, the latter probably being at the origin of this anomaly. But how? The origin of this huge ring of radio waves remains a mystery, and various hypotheses are being discussed. The first suggests that the galaxy in question experienced a period of intense star formation. Their successive cataclysmic births and deaths would have violently pushed back the surrounding gas and particles, triggering an expanding shock wave. The second theory suggests a collision between two supermassive black holes located in the interior of this galaxy. This strange radio circle would then be a shell formed by outgoing galactic winds. This scenario, if it exists, has never yet been observed, although it is one that greatly arouses the curiosity of astrophysicists. Finally, others believe that we are simply looking at the barrel of a powerful jet, emerging from the active nucleus of this same galaxy. As the exact origin of these strange radio circles remains unresolved, I suggest we divert our trajectory so as not to travel too close to this gigantic structure. After all, the consequences it could have on our interstellar journey are unknown. Now that we've reached cruising speed, I suggest you take in the scenery. Look out into the distance. The stars are covering the cosmos in all their glory. You have the privilege of admiring an area of space that is home to a huge cluster of galaxies. Meet the giant arch. With its crescent shape, this grouping extends over 3.3 billion light-years. Distant from our galaxy by 9.2 billion light-years, it is one of the largest structures ever observed. Made up of galactic clusters, galaxies, and abundant amounts of gas and dust, it stretches across nearly 1/15 of the observable universe. To give you an idea of its scale, the giant arc, if visible to the naked eye from Earth, would represent, despite its remoteness, almost 20 times the width of the full moon. If it was only discovered in 2021, it's because such a structure, according to established models of the cosmos, isn't supposed to exist. According to the Standard Model, the current theoretical limit predicts that the size of a structure should not exceed 1.2 billion light-years. And yet, the 45 to 50 galaxies in the giant arc are bound together by gravitational forces, as in any galaxy group. It was therefore detected by chance, while a scientist named Lopez was assembling maps of objects in the night sky using the light from 120,000 quasars. She then realized that the specific signature of certain halos from several dozen galaxies was similar. Mapped in 3 dimensions, the structure discovered turned out to have this atypical arc shape. To assess the probability of galaxies forming such a vast alignment in space, the scientists used 3 different statistical methods. All of them showed that the hypothesis put forward was not all that fanciful. The discovery of this gigantic galactic arc calls many things into question, but it's not the only one to baffle astrophysicists. The Great Sloan Wall and the giant GRB ring, with respective diameters estimated at 1.38 and 5.6 billion light-years, are 2 other unlikely groupings already observed. The Great Wall of Hercules Corona Borealis, visited a little earlier, remains the largest known structure in the universe, totaling 10 billion light-years, whose existence also continues to raise many questions. With our eyes immersed in this ultra-large structure, we've completely forgotten about our surroundings. Let's take a step back and look at the giant arc's surroundings. What do you notice? Isn't there another imposing structure looming in front of you? In this same region of the universe, close to the constellation Bouvier, another grouping of galaxies forms a gigantic ring of light. But unlike other circular structures, this one resembles a helix, taking the form of a complex spiral. While this unusual appearance is striking for any seasoned observer, its dimensions are once again beyond comprehension. This colossal structure, with a diameter of around 1.3 billion light-years, has only just been detected. The announcement of its fortuitous discovery was revealed, also by Alexia Lopez, at the 243 meeting of the American Astronomical Society, which has just taken place at the start of 2024. The Great Ring, as this new structure has been christened, is almost similar in size to the giant arch discovered 2 years earlier. If this structure could be opened up into a curved shape, its circumference would equal the length of the giant arch. To get a better idea of the ring's gigantic size, consider that if it were visible to the naked eye from Earth, it would cover the night sky like 15 full moons in a row. In addition to their extraordinary dimensions, i.e. in excess of 1.2 billion light-years, the theoretical size limit, these two giant structures also raise another question for cosmologists. Given that the giant arch and the Great Ring are located in the same region of the cosmos and at the same distance from Earth, is it possible that they are connected to each other? In short, that they are part of the same, even more extraordinary cosmological system? These latest discoveries add up to new evidence that compromises our current understanding of the universe. Once again, the cosmological principle that matter is homogeneously distributed throughout the universe may well be proven wrong. Shouldn't scientists start examining this possibility? Shouldn't they shatter what they once believed to be irrefutable, i.e. all manner of theories and rules governing the laws of the universe? Crazy as it may sound, many scientists say they're ready to consider it. But before they can do so, they'll need even more convincing arguments. For this, new research in the direction of as-yet unexplored objects or structures, which are consequently very difficult to detect, will have to provide new tangible proof. However, another argument is also being debated by astrophysicists. Some so-called impossible or early galaxies tend to confirm that the cosmological principle may well be obsolete. Thanks to new observations by the James Webb Space Telescope, scientists have discovered almost half a dozen galaxies that appeared just after the Big Bang, displaying unexpected characteristics. To everyone's surprise, these galaxies are so massive that they could call into question their very origin. Joel Leha, professor of astronomy at Penn State, announced that instead of tiny galaxies, they had detected disconcertingly massive ones. These turned out to be as mature as the Milky Way in a region of space then considered the dawn of the universe. The galaxies studied show a redshift, appearing to be approximately 13 billion light-years old. Admittedly, according to scientific consensus, our universe was born some 13.8 billion light-years ago. But that means they would have reached maturity in just a few 100 million years after the Big Bang. The idea is simply inconceivable according to the standard cosmological model. These luminous groupings of stars are so massive that they are impossible in 99% of models of the early universe. What's more, they are astonishingly small, adding to the mystery surrounding them. So how do we explain their existence? How can galaxies from the early universe be in such an advanced state of growth, corresponding to billions of years of cosmic evolution? For the researchers, there had to be a mistake. Although every effort was made to locate it, it could not be found. Could it be that galaxies were formed more than 26 billion years ago? That's what Rahendra Gupta, Assistant Professor of Physics in the Faculty of Science at the University of Ottawa, suggests. For this scientist, our universe could actually be twice as old as current estimates. This would not only shed new light on those impossible early galaxies, but also provide an explanation to the existence of stars like Methuselah, the stellar Doan that seems to have been shining longer than our universe. Rahendra Gupta is the originator of a new way of thinking and explains how his model stretches galaxy formation times by billions of years. In this hybrid model, he combines the evolution of Paul Dirac's coupling constants with a controversial theory, Zwicky's tired light theory. According to this theory, the redshift of distant galaxies is due not to the expansion of the universe, but to a gradual loss of photon energy. The photons would be progressively stripped of energy as they traveled the very long cosmic distance to the observer. As for Paul Dirac's coupling constants, these are fundamental physical constants that govern the interactions between particles. These may have changed over time. To sum up, according to the synthesis proposed by Professor Rahendra Gupta, the redshift exhibited by these incredible galaxies could be attributed to two phenomena. One is the expansion of the universe, the other is the fatigue of observed light. For the scientist, our universe could therefore be exactly 26.7 billion years old. The distant universe fascinates astrophysics experts and enthusiasts alike, all the more so when our Earth is hit by one of the most energetic cosmic rays ever recorded. Named Amaterasu, this strange cosmic ray was detected on May 27, 2021, by the Array Telescope Network. With its unrivaled power, it surpassed the first phenomenon of its kind detected in 1991, named Oh My God, and which motivated the Telescope Array project. Over the past 3 decades, more than 30 ultra-high energy cosmic rays have been detected, but none of them reached the power displayed by Oh My God until this latest discovery. Nicknamed Amaterasu after the Japanese goddess of the sun, this cosmic ray, composed of accelerated particles, is baffling scientists for several reasons. The first, of course, is its extraordinary power. The kinetic energy of just one of these particles has been estimated at that of a tennis ball thrown at nearly 150 kilometers per hour, or 90 miles per hour. While this ray, invisible to the naked eye, has remained in the shadows for the average person, it did not fail to panic scientists' measuring instruments when it was detected in the Utah desert. But even more disconcerting is the fact that nothing seems to be at the origin of such a phenomenon. Neither our galaxy nor neighboring galaxies. Indeed, after tracing its trajectory, the researchers were able to trace the source of this cosmic ray, or so they hoped. After all, it seems to come from a region of our universe that is virtually devoid of galaxies, and therefore relatively poor in matter. So how do we explain this flow of atomic nuclei and high-energy particles? What mechanism could have generated this extraordinary cosmic ray? Once again, to explain Amaterasu's origin, everyone has their own hypothesis. For some, it could have been particles emitted from our galactic surroundings. An event sufficiently discrete that no energy release or gamma-ray burst is detected by our instruments would then be the origin. This hypothesis calls into question the distant origin of the cosmic ray. A second theory suggests that the cosmic ray was deflected by an extragalactic magnetic field much more intense than originally thought. But the energy of the particles is so high that they should not have been affected by any magnetic field. Finally, the last hypothesis raises the possibility that this particle could confirm physics unknown to the standard model of particle physics. Critics also suggest that the Array telescope may have overestimated the energy of the cosmic ray. What's more, the exact nature of the particle detected is still an unknown factor that can change everything. Is it a proton? Or, for example, an iron atom? As in so many other cases, this discovery only adds more mystery to our universe, which is proving to be ever more complex. One of the most recent discoveries once again challenges our understanding of the cosmos. A team of astronomers from the U.S. Green Bank Observatory, led by Karen O'Neill, has just made an unprecedented announcement. A unique galaxy, christened J0613+52, has just been spotted. What's special about it? It has no visible stars. So the image we have of a galaxy as an immense grouping of luminous stars bathed in gas and dust is not always accurate. So say the astronomers who have just inadvertently pointed their telescope in its direction. The discovery, which was totally fortuitous, was due to an input error. As Karen O'Neill explains, an operator inadvertently set the Green Bank telescope to the wrong coordinates. Without this oversight, the object 270 million light-years from Earth would have remained in the shadows, and with good reason. It's a low-surface brightness galaxy, which is extremely faint, even for this type of galaxy. Aware of this parameterization error, the astronomers nevertheless decided to take a closer look at this structure, which at first glance seemed insignificant. Their curiosity paid off, enabling them to make a completely unexpected discovery. They soon discovered that unlike other galaxies with low surface luminosity, this one is particularly rich in gas. Its chemical signature suggests that it contains abundant quantities of primordial gas. Like spiral galaxies such as the Milky Way, it contains mainly hydrogen and helium. After measuring the wavelength shifts, an undeniable fact emerged. This galaxy seemed to rotate in the same way as an ordinary spiral galaxy. This gas cluster has all the characteristics of our own Milky Way. Its mass, composition, and motion all match, except for one thing. There are no stars in this vast gaseous region. Scientists have a new enigma to solve. Have they discovered one of the first primordial galaxies, which underwent no transformations during its 13.8 billion years of existence? Why didn't this galaxy, so massive and holding these elements formed shortly after the Big Bang, enrich itself, like its counterparts, through stellar explosions in the course of its evolution? For Karen O'Neill, the gas in this structure is too diffuse to allow it to collapse in on itself under the influence of gravity. What's more, this galaxy is totally isolated from any other structure in its immediate vicinity. It seems never to have been disturbed by any other galaxy. But these explanations are not enough to demystify this unique and fascinating recent find. Indeed, it's unlikely that over such a long evolutionary period, no gravitational force has ever disturbed its peaceful existence. And yet, this is what it seems to demonstrate. To better understand the nature and dynamics of the early universe, scientists will have to be patient. Future discoveries of cosmic bubbles that have not undergone any reshaping should help elucidate this anomaly, but they still need to be detected, as they are particularly discrete. Now it's time to return to our magnificent planet Earth. Let's plan our return. However, there's one last anomaly we'll need to overcome if we're to return in the best possible conditions. Our trajectory must absolutely avoid a vast zone located between South America and the southwest of the African continent. You may not know it, but this area is known as the South Atlantic Anomaly. It turns out that in this region covering the globe, a curious phenomenon has been intriguing scientists for several decades. The intensity of the Earth's magnetic field is unstable and much lower than in the rest of our planet. If we were to cross this zone, the consequences could be terrible for our spacecraft. Bombarded by high-energy particles emanating from our sun, all onboard technology could suffer interference, or even worse, a disastrous malfunction. But rest assured, this phenomenon, although unexplained, is not new, and we know perfectly well how to dodge it to bring this fantastic voyage to a close.